recording, Doctor.
Yeah, sure. Oh, somebody put recording. It's recording. You started now or before? All right. Bismillah ar-Rahman ar-Rahim. Yeah. Last thing I talked about in chapter chapter 13 was this law. What's this? The name of this law?
Henry's law.
Henry's law. Forget it. It's related to what? It's related to gas and liquids. Gas and liquids. What's C?
Concentration.
In what unit?
Molar.
Molarity. Okay, what's P?
Partial pressure.
P in atmosphere, partial pressure. Not any pressure, but the partial pressure, atmosphere. And what's K?
Henry's law constant.
Henry's law constant. And I gave you this example. Okay, when you have soft drink, when you bottle it, the partial pressure of CO2 is 5 atmosphere. So what will be the concentration if K is given to you here? This is K. Okay. So what C is going to be?
B multiplied by K.
A by multiplied by P, which is already here. Now, when we open it to the air, what's the pressure of the air approximately?
1 atmosphere.
1 atmosphere. But what's the pressure of CO2 only?
0.5.
0.003.
Much less than this. It depends on the concentration of CO2. It was found to be 0.0003 atmosphere, which is very low. So what will be the concentration in this case? We apply the same law here, but now the concentration, we do know K is the same, and then the pressure is 0.003. Is this clear? Any question about this law?
Yeah, Doctor, I couldn't quite understand
You didn't understand what?
how we solved it. I mean, where did we get the pressure of CO2?
As I said, this is the partial pressure of CO2. You know, the air, the pressure of the air is equal to 1.00. This from chapter 10 now, atmosphere. What's the pressure of N2 approximately? N2.
Less than, has to be less than.
What is it? We almost know it.
0.7.
79. Approximately. What's the pressure of O2?
How we know, Doctor?
Well, you know what's the component of the air? What are the components of the air? الهواء يتكون من ايش؟
Gases.
21% oxygen and 79% nitrogen.
Exactly. 21% O2, 79% N2. And the rest are very, very small. I did not give it to you here. But if we have 1 atmosphere outside, there will be 0.79 atmosphere of nitrogen, 0.21 atmosphere of O2, and the rest is very, very small. Here I just give it to you that PCO2 is equal to 0.0003 atmosphere.
So it will be given, yes?
It will be given to you, yes. But you should expect it to be extremely low. Good. Next, colligative properties. Next, that's also I want you to memorize the name. What's the name of the scientist? Raoult's law. Raoult's law. You must memorize it. What is this Raoult's law? It says that when you have a solution, when you have pure solvent, then the pressure of the solvent is P10. Why? Because every solvent have a certain vapor pressure, certain vapor above it. All right? If this is water, for example, then there will be some water vapor outside. The pressure of the water at a certain temperature is equal to P10. Clear? That's the pressure of pure solvent. Now, if you put any solute, this is solution, this is solvent only, pure solvent. But if you have solution, then you have this, the solute plus solvent. All right? Now, solute plus solvent. If you have solute plus solvent, then what will happen? The vapor pressure will be less. The vapor pressure will be less, and we're going to call it P1. So P1 is the pressure of what? The vapor pressure of what?
Solution.
Solution. Vapor pressure of solution. What's P10?
Pure solvent.
Vapor pressure of solute.
Vapor pressure of pure solvent. Pure solvent. Clear? Okay. What's X? We saw X before.
Mole fraction.
Mole fraction. And when I say 1 and this is 1, so it will be the mole fraction of what?
Solution.
Solvent.
Solvent to the solution.
Moles of solvent divided by moles of solvent plus moles of solute. Clear? So you have to find the mole fraction of solvent and solute. Is this clear?
Yes, doctor.
Calculate the vapor pressure of water over solution made by dissolving 225 grams of glucose in 575 grams of water at 35 degrees centigrade. At 35 degrees centigrade, the P0 of H2O, which is P10 in this case, is 42.2. So go ahead, solve this problem. What's the first thing you're going to do?
Find the
Calculate
moles.
the mole fraction.
Okay, moles H2O, calculate it. Give me answer.
Uh, 31.92.
9 what?
2.
160.
92 mole H2O. Very good. How many moles?
1.249.
What is it?
1.249.
1.249. Who got the same answer?
I got the same answer.
Good. because the mass is given to you. 1.249 mole glucose. Now, what's the mole fraction of H2O?
Doctor, doesn't have to be the mole fraction of glucose.
No, that's why I say it's X1 and the law. You remember the law? P1 equal to X1 times P10. So everything 1 means solvent.
0.996.
Good. 0.962. Very good. Now, what's P10?
42.
42.2. So what's P1? Go ahead.
Doctor, it should be in atmospheric pressure, right?
Or P.61.
40.61.
40.61.
Yes.
The answer,
Yes.
no, it doesn't have to be in atmosphere. Well, it depends on the question. If I ask you to give it to me in atmosphere, then you divide this number by 760. But I want it in millimeter Hg. Can I make it atmosphere?
Divide by
Divide by 760.
That's it. If you want it atmosphere. But this is enough. So this is the answer. How easy?
Very easy.
Good. Next. If you have two solvents dissolved together, two liquids dissolved together, then everyone will give you vapor pressure. This is the vapor pressure of the first one. If you have two liquids, question, what did we have? We have solid and liquid, right? Because glucose is what?
Solid.
Solid, and then it's in liquid water. But if you have two liquids, then if you have two liquids, each one will give you pressure. So if you want to calculate the pressure, you have to calculate the pressure of A and then calculate the pressure of B. Clear? This means you have to do each one of them by itself. I just want to say one thing here. XA plus XB must be equal to what?
1.
1.
Exactly. XA plus XB is 1. So if I want to calculate the pressure of each one, I should do whatever I did there. This is question, but I did it for the two of them, each one of them. So we did this, we put B1 and V1 for the liquid. In here, I have to do it for two liquids. Clear?
So this means how many solution?
What?
How many solution?
It's one solution. They are mixed together. I want the total vapor pressure. يعني الآن see, that's the answer to the question. See, if I have pure benzene, this is the vapor pressure of pure benzene. And this is the vapor pressure of toluene. But if I want the total pressure, it will be depends on what's the pressure of each one of them at a certain component, and it's the total of the two. So this is the pressure of benzene, and this is the pressure of toluene by itself. And as I said, X of toluene and X of B, which is this is if this is XA and this is XB, then This is equal to 1 minus expansion. Is this clear? So, in another word, let's go back to the equation, the simple equation. If I want to do for two liquids, I have to do the problem that I did here for each one of them by itself, and then add them together. Clear? So, what will be the B total?
BA plus BB.
BA plus BB. That's it. So I have to do each one by itself, and then the B total will be BA plus BB. Is this easy?
But for solid and liquid, we use the previous equation, only one.
Yeah, if it's solid and liquid, because there is only one liquid, so we did for one liquid only. This is in solid and liquid. Is this clear?
Yeah, doctor, but in this case, what's the difference between PA and PA0?
It's the same. Or for pure, if I tell you the benzene, the vapor pressure of benzene is, for example, 40 at 4 millimeter Hg. Okay, what will be the PA? This is P10 is 40. What's PA? It depends on the mole fraction of benzene times this one. Is this clear?
Yes, so PA...
PA0 will be given to you.
Okay.
This is given to you for pure benzene. Clear?
Yes, yes.
Okay. And this one is the BB will be also X toluene in this case times PB0, which is the pressure of, this is the pressure of pure toluene. Okay, PP0 will be also given to you. So you calculate the mole fraction and calculate BB and BA, and then if I want the total pressure, P total, I add them together. Is this clear?
Yeah, so PA is part of the total pressure.
PE is what?
PA, when
Yes.
we're calculating PA or PB, we're calculating parts of the pressure,
Exactly.
total pressure, and then adding, okay.
P total is adding them together. Exactly, yes. How easy?
Easy, inshallah.
Good. Now, next. When you have water, the water H2O, what's the freezing point of pure water?
0.
0.
0.
What's the boiling point of pure water?
100.
100 degrees C. Okay. This is for pure water. If you have solution, then what will happen? The freezing point will be lowered. So we say freezing point depression. What do you mean by freezing point depression? It will be what?
Less.
Less than 0. Okay, here clear. And the boiling point will be elevation. What's that? What does that mean?
Greater than 100.
Greater than 100. And it will be like this. So this will be boiling point elevation. And this will be what? Freezing point what?
Desperation.
Depression. Depression, نزول. All right? Okay. And delta T here, what will be the delta T? If for example, this one at -5, what will be delta T?
Less than 100?
No. What's delta T in the freezing point? It will be 5.
5, yes.
It's the difference between these two. What will, if this is 120, for example, what will be the delta T for the elevation?
20.
20.
And this delta T freezing is 5. Is this clear? Now, the relation between them, I want you to memorize it. This is delta T is equal to what? KB times M. What's M?
Molality.
Molality. Molality, not molarity, but molality. And what's delta T?
Difference in temperature.
Delta TB. Boiling point change. And what's KB?
Molar elevation
Constant.
constant.
Molar boiling point elevation constant. Okay, and then I will give you the other law. It's written in the other page, but if I write delta TF, what will be the answer? Is equal to what?
KF
KF times
times
M.
M.
Times
Molality.
molality. So you know these two laws. Don't forget, we're using here molality. Okay, good. Okay. Ethylene glycol is a common automobile antifreeze. That's the thing that you use in your car. حق التبريد.
Radiator.
Radiator, yes. It's called ethylene glycol. Ethylene glycol. Okay. It is water soluble and fairly non-volatile. All right. So we dissolve it in water and give it to you and sell it to you. Calculate the freezing point and the boiling point of water if we contain 685 gram of ethylene glycol in 2075 gram of water. The molar mass of ethylene glycol is 62.07, and Kf and Kp of water is given to you here. Okay, so we want to know what will be the freezing point and what will be the boiling point. What's the first thing you're going to do?
Calculate the molality.
First moles of ethylene glycol. What's the moles of ethylene glycol?
$11.035.
11.004.
04.
Good. Okay. 685. I divide 685, which is the mass of ethylene glycol, by the mass, the molar mass of ethylene glycol. Okay. What's the next step? I want to know how many kilogram water I have. Right? What's the molality?
$5.32.
5.32.
Very good. 5.32, because this is the mass of water, I made it in kilogram, and then calculate the molality. Yes, good. What will be delta T boiling?
KB times 5.32.
Yes, what's KB?
0.52.
0.52.
And what's the answer?
2.7.
2.766.
2.77
77.
or 76, no problem. 2.8. I'll take this. Okay, what's delta TF?
KF times molality.
5.32 times 1.86.
It will be 9.89.
9.9.
9.89.
9.89. Good. All right. Okay, good. What will be the boiling point of solution? Boiling point of solution.
102.8.
Exactly, 102.8. And what will be the freezing point?
Minus 9.89.
Minus 9.89. How easy?
Doctor, how we get it?
What?
How we get 102.8?
Because we know the freezing of pure water is 0, and the boiling of pure water is 100. What will happen if we have solution? The boiling point will increase, and that's why it became 102. And the freezing point will decrease, and that's why it became minus, below 0, minus 9.89. Right?
Doctor, how are we able to calculate the change in boiling point?
You know what's the you know the law? What's the law? Delta TB equal to what?
I'm not too sure.
We just gave it to you.
I wasn't able to memorize it, my bad.
Delta TB equal to KB times molality. And delta TF equal to KF times molality. That's the change in temperature and freezing, and that's constant and molality. And that's what we did here exactly. Delta TB, first we calculate the molality and multiply the molality times KB. This KB and this KF. How easy?
Doctor, about it gave us something in the question where it says the boiling point is 197 degrees Celsius. Did we use that for something or not?
Where did it say this?
At the end of the first paragraph.
Oh no, this is this is boiling point. The boiling point of no, he just wants to tell you that it is very far from 100, so it will not boil. This is not important. Yeah, got you. Yeah, this information is not needed. It just wants to tell you that don't worry, nothing will come from the ethylene glycol as vapor. So this is not important.
Then, Doctor, how did we calculate the boiling point of the solution? We got the change, but why did we use 100?
Because it's what's the boiling point of water.
Oh, so we added to the boiling point of the solvent?
Of course.
Okay.
Yeah, of course. It's 100, and it will be higher than 100. When you calculate delta P, you add to the boiling point. Maybe 100 for water. For something else, maybe it's not 100. If it's in ethylene glycol, or if it's in, for example, in alcohol, it will be less than 100, whatever. Then you add it to the normal boiling point of pure solvent. And for the freezing, you subtract it from the freezing point of the solvent. What's the name of this, the thing that we just did now? What's it called? Freezing point what?
Elevation.
Freezing point, no.
Depression.
Depression.
And boiling point?
Elevation.
You have to memorize the equation, of course. Don't forget to memorize how to calculate delta T and delta P. Last thing we're going to talk about is called osmosis. Osmosis. What's the meaning of osmosis? Osmosis means والله ما أعرف شنو بالعربي. I don't know what it means.
الأسموزية.
ضغط الاسمه.
أعتقد بترجمها بالعربي نفس الاسم osmosis. إيش
الخاصية الأسموزية.
الخاصية الاسموزية. Okay, if you have two solutions like this, this is for example pure solvent, and this is solution. Each one have different pressure, right? Why? Each one has different vapor pressure. Why is that?
Different substances.
No, it's
different molarities.
no. Remember Raoult's law?
Solution has less vapor
Raoult's
pressure.
law.
Different concentration.
What's Raoult's law? That's Raoult's law. What's Raoult's law?
Action, doctor.
The vapor pressure of solution and the vapor pressure of pure solvent, and the relation between them, right?
Yes.
Right. The mole fraction is always what? Higher or less?
Less than 1.
Is that one?
Less than 1. طيب إذا مين اللي أكبر P1 ولا P10?
P10.
P10.
P10 is always bigger. Clear? So let's go back to osmosis. Okay, what will be the pressure of the pure solvent? Right?
More than the pressure of the solution.
What will be the pressure of the solution? It will be P1. Which one is bigger, P1 or P10?
P10.
P10. Okay, because this one has pressure, this will make the solution goes from this side to this side. If we have in here in between them, we must have what's called, this is, you must memorize this word, semi-permeable membrane. Semi-permeable membrane. This is what's called semi-permeable membrane, which allows small molecules to go through, but not allow big molecule to go through. And because the pressure here, P10, is bigger than P1, what will happen? Because there's more pressure here, the molecules will go from this side to this side. That's what's called osmosis. And we we call this one bind. So what's this? This is called osmosis, and it is called bind. What's the name of the barrier here? ايش اسم الحاجز؟
Semi-permeable
membrane. Semi-permeable membrane. What's the meaning of semi-permeable membrane?
It only lets small
نفاذية
particles.
متوسطة. نفاذية متوسطة.
The small particle can go through. It can go here and come back, no problem. But the big molecules will always stay in this side. The difference between the pressure of P10 and P is called osmosis bind. Clear? And that's why what will happen if we keep this, if they have the same level, but after a while what will happen? This level will be less than this level. Why?
Because the pressure will be equal.
Yes, because some of the molecules will go this side because of the pressure, and this will increase this one, and now the pressure is equal. This difference in pressure is called what?
Osmosis pi.
Pi or osmosis. Pi or osmosis. Is this clear? Now احنا في السعودية نستخدم هذا البروسيس a lot. كيف نستخدمه؟
Oil.
Water.
Oil.
Desalination. ايش معنى desalination؟
تطير.
ترشيح.
تحلية المياه. تحلية المياه. Okay. What do? We have this solution and we put semi-permeable membrane and then we put a lot of pressure here. If we put a lot of pressure here, what will happen? احنا نحط pressure. يعني احنا نضغط هذا. When you put pressure here, what will happen?
We will get only pure water on the
and the water will go this side because the water can go to the other side. Is this clear? Now this is called, I repeat, the difference in between them, if there is no pressure at all, let's take this. Because this one is pure, P10, and this one is P1, the pressure here is bigger than this one. As a result, the solution will go from this side to this side. Clear? At the beginning. But now, this will go from this side to this side because the pressure here is bigger. Now, if I take this away, oops, now, if I put a pressure here, يعني أنا حطيت pressure here، جيت وضغطت هذا، حطيت هنا ماكينة وجلست أضغط بكل قوتي. piston. فلما أضغط إيش هيصير؟
Pressure P1 will be bigger than pressure P10.
Of course, not the pressure P1. The new pressure, this pressure which is called I break, I'll call it BA, is much bigger than P10. This BA, it's not because of the solution, but because of. So what will happen? It will start to go to this side. This is called reverse osmosis, RO process. وهذا الطريقة اللي نستخدمها للتحلية. RO process. RO process. Okay, good. Now, I want you to memorize this law. This bi, which is the osmosis, equal to MRT. Bi, what's bi?
Osmosis.
3.14.
No, it's not 3.414. This is bi, which is not 3.14. There's the difference between the level here and here. This is bi. Clear?
Clear.
Okay. Osmosis pressure. And what's M?
Molality.
Molarity. And what's R?
0.08206.
Gas constant. What's gas constant? This is the gas constant. You remember the gas constant. And what's T?
Temperature in Kelvin.
Temperature in Kelvin. Temperature in Kelvin. Okay. So I'll stop here. But if I want to calculate the bi of the solution, what should I calculate first?
Molarity.
Molarity. So you can see we use molarity, we use molality, we use mole fraction. Can you see that? Okay.
Yes.
So I want to very quickly tell me what's Raoult's law.
One fraction.
Raoult.
P10.
This is called Raoult's law. I want you to memorize it. What's the freezing point depression?
TB equal to KB
Delta
multiplied by
TF is equal to KFM.
Delta TF equal to KF times
Molality.
molality. What's boiling point?
delta TB multiplied by KB multiplied by M.
Delta T boiling equal to KB times molality. Then what's by? Last thing.
Molarity times R times 10.
MRT. I want you to memorize this very, very well, all of them. And tomorrow, I'm going to continue we'll finish tomorrow the question, and we will solve lots of problems related to this. There is one more subject we're going to talk about tomorrow, and this is the end of the lecture today. See you tomorrow, inshallah, for normal lecture, inshallah.
التحضير دكتور.
Yes. Now, it's open for you. You go ahead, take تحضير مع السلامة.
يا دكتور جامعة الكويت متى تطلع؟
الآن بعد ما نخلص التحضير نسوي كل شيء.
دكتور أنت بتاخذ الآن 5 كويزات ولا 6 كويزات؟
6 طبعا. من هدف واحد.
دكتور كلاس وورك متى بينزل يعني نقدر نعرف؟
إن شاء الله لما أخلص ما أدري.